Let's begin the next video lesson. Today we'll be looking at a section 4.4, simplifying fractions. So let us begin. Some terms for us to go over in this section. One is something called equivalent fractions. And equivalent fractions are fractions with different numbers, but they are equal to each other. So, for instance, let's say we have two fractions like, or let's take this one first, 1/2. You can write 1/2 as 1 over 2, but its value doesn't change just because you change the two numbers. This is an example. 2 over 4 or 5 over 10. I hope that you can see that this is still equal to 1/2. If you have 2 over 4 and 5 over 10, these could reduce back down to this. They're the same value. If I cut a pizza into 2 slices and give you 1 piece, you have half the pizza. If I cut a pizza into 4 slices and I give you 2 of the slices, you have half the pizza. If I cut a pizza into 10 slices and give you 5 of the slices, you have half of the pizza. So I hope you really do see that equivalent fractions, once again, have different numbers, but they're still equal to each other. Here's another example. 5 over 3 is the same as 6 over 10, 9 over 15, or 30 over 50. These are all they're equal to each other. They look different, but they're the same overall number. They have the same value, you could say. All right, next. So here we're going to write some equivalent fractions, and your work will vary on what the directions might look like. Like it might say write 2 equivalent fractions, or it might say write 3 equivalent fractions, blah, blah, blah. Now you can write equivalent fractions a multiple of ways. One, you can do it by reducing. So let's say this said write 2 equivalent fractions. So we could reduce this fraction here because 2 goes into both of them. So I could divide both by 2. I could get 2 over 6. And I could also then reduce that again to 1/3. These are equivalent fractions. They're equal to each other. So, but you can also get equivalent fractions, as you'll notice up here, by multiplying both top and bottom by the same number. So for instance, if I could multiply the 10 times 5 to get 50, and I could multiply the bottom number by 5 and I get 60. So 10 over 12 is the same as 50 over 60. I could also reduce that down to 5 over 6, okay? So these are examples of equivalent fractions. Simplest form. Simplest form is when we're given a fraction that is written with large numbers that can be reduced down. So let's take a look at some examples. So write in simplest form, it will tell us. And we're given some fractions right here. So you have 2 options to get to the simplest form. One option is what we would call multi-stepped. It's where you have 8/12 and you go and you decide to reduce it down. So like 2 goes into both of these numbers. So I could reduce that down to 2 goes into that 4 times, 2 goes into that 6 times. If you're paying attention, you'll notice that this number itself can reduce down to 2 over 3. All right? So next, as we're done, actually it can't reduce anymore. There is another method, and it's where you find the GCF. Now both of these are going to get us the same answer. One just does it in multiple steps, one does it in 1 step. This is the 1-step method. It's where you actually take a really good look at 8 and 12 and you say, well, what's the greatest common factor between these 2 numbers? It's 4. Well, if I reduce this by 4, I would get 2, reduce that by 4. I mean, you divide it by 4. You would get that to be 3, and so that's you're done. It's in simplest form. So you see, one method gets you there in a few steps, one gets you there in 1 step. Now, you might not always be able to find the GCF easily, so you might just need to divide in the multi-step method. Remember, a good test, and I do get annoyed if students don't test using this method from the beginning. You need to take a look at it and say, is it even? Or is it, is it even, odd, and all that stuff? If you look at it and notice that you have two even numbers, it's always going to be able to reduce. So I'll finish giving these examples. Just take a look at this for just a minute. So, sorry about that. Let me see if I can fix this. There you go. All right, so these next examples, let's see if we can simplify them. Now, I know you'll be thinking, wait a second, what happened? Those were numbers. These are letters. All right, letters do not make this more difficult. Here's how easy letters are. Basically, if they don't have exponents, what you can do is you can cross out the letter for each letter type of thing. So you can basically go through and you can be like, where? Look at what I've got here. I've got me an X at the bottom, and a Y right there, and a Y right there. Make sure that looks like a Y, not an X. And you can basically say, well, that crosses out, that crosses out. So those are gone. Those are gone. I'm left with an X in the denominator. Now, you don't just put 0 up here because nothing's there. You actually replace it with a 1. And we'll go over more of why that is. If you want to put a question mark by that, or if you understand it, that's great. Maybe I'll ask you to help explain it in class. But you get 1 with X on the bottom, because those guys leave, and you're left with a 1 up here. Because the reason why is because there's an understood 1 in front of that Y. And so when he disappears, the 1 has to step up and fill the space, okay? So that's where that 1 comes from. So over here, we got some stuff to reduce. Now, what you need to do is you need to write out the exponents. So we're going to write down our 5 over 15, extend this a little bit. I've got A times B, A and C. Okay, so I can cross out this A because I cross out this A, okay? So I'm left with an A on the top and a B and a C on the bottom. Can this reduce? 5 over 15. I could be wrong, but I think that reduces to 1/3, doesn't it? Because 5 goes into 5 one time, 5 goes into 15 3 times. So I end up with 1, 3 on the bottom, the A is on the top, the B is on the top, and the C is on the bottom. So I have 1AB, 3C. Okay, let's take a look at another one. Once again, I'm going to write these down. I'll make sure my numbers are over here, so they kind of look like a regular fraction or an improper fraction in this case. I have my A and my B. Actually, I'm going to write down B and B. Okay, get rid of that little line up there. And then I get B right here. So I cross out my letters that pair up. So like squiggle that one out, squiggle that one out, squiggle that one out, squiggle that one out. Okay? And 30 and 5. I think 5 goes in this one time, and that goes in 6 times, so you're going to end up with 6 over 1, but that's just equal to 6. So you end up with 6, and then you still have this B and B here. Well, B times B is B squared, okay? So that's your final answer. After you simplify this, you would get that. So these are our answers here, and we'll, like I said, we'll look more over these problems as we go on, okay? Now, we do need to cover something else because this section is not going to take up a lot of time. We are going to go over this next section, which is a very simple section. It's called rational numbers. And I made a little chart here for you to take a look at, and you can pause the video and copy this down, but you might want to listen to my explanation, then copy it down, so you understand what you're doing while you're writing it. Here you have whole numbers, integers, and rational numbers. Now, whole numbers you've dealt with since elementary school. It's like 0, 1, 2, 3, 4, 5, 6. You get the point, right? I hope so. They're all the whole numbers that are positive. Integers include, once again, all the whole numbers, but they also include negative numbers. So I want you to see that integers include whole numbers and their opposites, meaning the negative groups. Rational numbers include the whole numbers and the integers, and they include fractions and decimals. But they only include certain types of decimals. They include decimals that come to an end, and they include decimals that might have a repeat in them, like these two have a repeat in them. It does not include decimals that go on forever and never repeat, like pi. Pi is an example of an irrational number. It's a group way over here off to itself. It has its own little universe that it floats around in with a few other special numbers. But we're not dealing with irrational numbers right now. Well, that's for much later on. We're just concerned with rational numbers. Rational numbers, another way of putting it is a rational number can be written as a division problem. You can write it as a fraction, basically, because a fraction is just a division problem, like this right here. We know that's 6/7, but another way to say that is 6 divided by 7. So that's what we do there. So there's a few things to learn as we look at these rational numbers, and here's what we're going to learn. Write 3 equivalent fractions. We've done stuff like this, but here's some things that we need to know. Last section we did equivalent fractions, so we know that we could write something like, I could say, well, 2 times 2 is 4, and then 2 times that I get 6. So I know that. But something else you can do that's an equivalent fraction that makes it look different is I could say -2 divided by -3. That's an equivalent fraction. And some people say, wait, but they're both negative. Right, but a negative divided by a negative is a positive. So even though we have 2 negatives here, the overall value is positive. Okay? And that brings us to another point we need to make. Look at this fraction right here. I have -4/5. -4/5. You, of course, could write that as negative as an equivalent fraction. You could say it's -8/10. You see, we just kind of, we increased it, but it's still the same. But something else you can do is you can say -4/5. You can also say 4/5. Or like this one up here, I'll just make sure you see this here. You could put negative, and the whole thing is basically what you're saying is negative. Either way, this is saying that the fraction is negative. This is still saying the fraction is negative because if you have a negative divided by a positive, its value is negative. If you have a positive divided by a negative, its value is negative. So it doesn't matter which way you do it, these equal each other. I just want you to know that these 3 are equal to each other, but if I put one that had 2 negative symbols, it would not be equal to it. Because if I put 2 negative symbols there, that would make it overall positive. And it's supposed to be negative, so yeah. So make sure you pay attention to stuff like that. Put a question mark by it if you don't get it. All right, next we have over here, so I could put 10/16. I could put 50/80. That's equivalent. And remember, I can also do the whole -5/8 because its overall value is positive. Okay? So I hope that I think that's it for right now. We'll go over some more stuff about what this looks like in class, but I think that'll get us where we need to be. All right, look back over your notes, see if you got any questions, and be prepared to discuss in class.